let us kick this off. Good morning, everyone. My name is Matt Klassen. I'm the Executive Director of TMA BlueTech. I want to welcome everyone to this month's iteration of BlueTech Global Connect. Today, our topic is Offshore Renewable Energy, plotting a course from oil and gas into a sustainable energy future. We have again arranged a fantastic panel today. Our moderator is Larry Utker. He is the Executive Director for Humboldt Bay Harbor Recreation and Conservation District. Our presenting companies are going to be Jonah Margulis, the Senior Vice President at Aker Offshore Wind. He's also the Vice Chair Board of Directors for Offshore Wind California. We have Sam Salustro, the Director of Coalitions and Strategic Partnerships at B Now, otherwise known as the Business Network for Offshore Wind. We have Ryan Davidson. He's the Business Development Lead at Cal Wave Power Technologies. And finally, we have Talia Kruger, the Senior Business Development Manager at Principal Power. So before I hand this over to Larry, and for those who don't know, TMA BlueTech is a California-based nonprofit that promotes sustainable ocean-based ocean and water technologies. Our tagline is promoting blue tech and blue jobs. We are based on the triple helix, which brings together academia, policy, and industry to further the cause of sustainable blue tech. Our three areas of focus are economic development, business ecosystem development, and national and international outreach. Just want to tell people that our 14th annual BlueTech conference will be held in person again this year. It'll be from November 14th to the 18th. BlueTech Week is one of the world's premier BlueTech conferences, where we bring together just a completely fascinating array of high-level professionals from around the world to talk about the state of blue tech through the lens of academia, industry, and policy. This year's agenda we're really proud of it. It is going to bring together the absolute latest in blue tech advancements in a range of sectors. If you want to keep abreast of those developments, speakers who will attend, panel updates, VIP attendees, you can follow us on LinkedIn. I will put that LinkedIn link in our chat box after I hand the panel over to Larry. Also want to say that, as you know, TMA BlueTech is a member-based organization. So if you join as a member, you get free access to BlueTech Week's Summit and Expo. This is a $600 value. You also get the benefits of membership over a 12-month period. So if you want more information about membership with TMA, I can put the link in the chat box as well. So as you probably already know, we're recording this webinar. For those of you who would like to reference this webinar at a later time, we'll post it on our YouTube channel within 24 to 48 hours of this event. Finally, a few housekeeping topics. Our presenters will have 10 minutes to present. At the 9-minute mark, I will give a signal that 1 minute is remaining. Other than this, Larry will facilitate the discussion, especially the Q&A at the end, where we should have about 20 to 30 minutes for discussion. And if you'd like to ask a question, you can write it in the chat box, and we will make sure it gets asked during the Q&A. So with that, I would like to hand the table over to Larry with the Humboldt Bay Harbor Recreation and Conservation District. Larry, the floor is yours.
Well, thank you so much for inviting me. I really appreciate it, and I'm so glad we have such a great panel. For those of you that don't know, Humboldt Bay is the second largest bay in the state of California, and we're about 90 miles south of the Oregon border, about 250 miles north of San Francisco. And so we've been planning a new heavy lift marine terminal for the offshore wind industry for the last couple of years. And so what I plan to do is to kind of give you a quick round robin. I would call it like speed dating. I would encourage you to turn up your microphone and just sit back and relax for a minute because I'm just going to go relatively fast and lay the groundwork for sort of where we're at. And then I'm going to turn it over to the individual panelists to give their presentations and then a questions and answers. And so you could just bear with me for just 1 second. Could you allow me to share my screen? I'm sorry. Okay, so basically with the Biden administration really did an acceleration of offshore wind, and these are all the places that are planned to be on the path for offshore wind by 2025. In the state of California just announced new ambitious goals by having 3 gigawatts by 2030 and 25 gigawatts by 2045. And basically the big picture for California is that they want to get rid of all gas-fired power plants in the entire state. And so this is basically their integration plan. And there's this complete overarching strategy to remove all gas-fired power plants in the entire state and basically get the state onto electricity. And so how are they going to do that? Basically in phase one, looking at the Humboldt Call area, which is 21 miles directly offshore of Humboldt Bay, 21 miles right offshore, and then Morro Bay, which is in Central Coast. And in the Central Coast, there's no ports between San Francisco and Port Hueneme. There's no ports in the entire state of California where the Morro Bay Call area. And the future phases are really Cape Mendocino, which is 100 miles from Port of Humboldt, Del Norte, which is right on the California-Oregon border, Diablo Canyon, which is down in the Central Coast, and then a couple of call areas off of the state of Oregon. That's just kind of is the plan of how are they going to roll this power out. And so if you really think about this is, 20 gigawatts, and I know they said 25 gigawatts, but if you say 20 gigawatts and use 15 megawatt turbines, that's basically 1,334 turbines, which is 67 turbines a year, 1.25 turbines a week. That's a lot of cranking out. We got to get the show on the road, and this is a major impact on the blue economy. Basically, the projections are about 14,000 jobs, 20 to 50 billion GDP, and lots of port infrastructure and other economic investments in the blue economy. So these things are huge. They're gigantic. They're floating. They're not fixed on the ground because it's deep off the Pacific Ocean. And so we're talking about 15 megawatts is what we're planning for. This is the Golden Gate Bridge in the background. And when they deploy these, they're fully upright. And so they can't go underneath any bridges or overhead obstructions. And again, if you take the foundations, and you look at those and you lay those on like the Giant Stadium in San Francisco, it gives you a perspective of what one of these might look like. And so I'm not advocating for anything. I want these built in America. Fast and furious, I have no holds about it. We're not building these in Asia or Europe. We're going to build these on the West Coast of the United States. And so basically they'll build these foundations on land. And then most likely they will transport those on a semi-submersible barge. And then once they're submersed, they will begin to build these towers fully erect in port, fully erect. And again, to the nacelle, we're talking about 450 foot tall, to the tip of the blade, about 600 feet tall, directly in port. And so then what happens is they will essentially tow them fully upright out the port and out to these call areas, and then they will anchor them in place. And so really within the blue economy, how do we build this supply chain and how do we get this economic growth? And where do we get all of this equipment, the nacelles, the blades, the hubs, the towers, the foundations, cable arrays, powers? Where do we get all of these things? And where do we get the workforce in order to really do this and bring all this stuff online? So we're talking about metal bending factories, blade factories, the nacelle factories, anchoring systems, the undersea power cables. And when you really start to look at this overarching industry, this is a major, major impact on the blue economy, not just on the West Coast of the United States, but this is happening all over the world. And these industries are essentially coming online, essentially all at the same time. And so the existing supply chain cannot supply Europe, the East Coast of the United States, the Gulf Coast, what's happening in Asia, South America, all of these different places. And so the West Coast is going to need to have new industries come online. And so within the power structure, how do you get all this power and how does that get integrated into this power grid that California was talking about replacing all of the gas-fired power plants in the entire state of California? As an example, between Denmark and the UK, they have the world's longest power cable, 475 miles long, that is in operation. And if you look at the existing undersea cables, broadband power cables all over the place in the world, where are these existing power cables? And if you look at the West Coast of the United States and you say, where are these existing power cables? And then again, you look at Humboldt, Manchester, Morro Bay. Look at where these power cables land. This is really critical. Wherever you have these offshore wind, you have to have these landings. There's these existing cable routes that are already approved. And if you take a look at those and you outline those over the call areas and you say, how are we going to get these power integrated into these systems? And you look at what the state's plans are, And then just to sort of hone in just quickly here is last year, this was approved by the state of California, and they're actually installed right now. These broadband cables that go to Humboldt Bay, directly to Humboldt Bay. And if you look at the offshore wind call area, you'll notice those broadband cables, they'll go directly through the call area. So how do you get the power? How do you get the cable? How do you get the supply chain? How do you get all of these things together? And so then in Humboldt, what we looked at, again, if you sort of look at this offshore wind call area in Humboldt Bay and where these cable landings are, and then we developed this master plan. Here, the cable landings are in this area. We have identified about 170-acre location, which includes about 600,000 square foot of manufacturing facilities, which could be utilized for those manufacturing, the supply chain, this whole blue economy. How do we get this thing going? And how do we get the efficiencies together so that we could do the vertical assembly and tow out the port? Another alternative is that we could lease to two different ones simultaneously. And so what I wanted to do is really give you a kind of a round robin, just a quick snapshot look of the West Coast offshore wind industry and kind of what the issues are for the blue economy. And when we think about the blue economy, really, it's any jobs that are directly associated with the ocean and the industries that take place out there. And a lot of those industries, they start on land, and they're really good, high tech and long-term sustainable jobs, and then integrating those into the offshore platforms that are going to be replacing the oil and gas industry in the California in particular, but definitely across the United States over the next 25 years. And so that's kind of is my introduction to offshore wind. And so I think that the panel is going to go into a little bit more detail from the individual perspectives of the companies, but I wanted to kind of provide this broad brush kind of overview. And so Talia, I was kind of hoping that we could start with you and to talk about kind of the foundation system.
Yes, certainly so. So if I can share my screen, that would be nice. All right, everybody, thank you very much for the introduction. It was excellent, an excellent overview of what is happening and this one of a lifetime generational opportunity. So my name is Talia Kruger, and I welcome all the TMA BlueTech attendees. I am the Senior Business Development Manager for Principal Power in charge of the Americas. The course away from fossil fuels to renewable energy has been set, and there is no going back. This presents us with interesting challenges and, of course, unprecedented opportunities. I'm going to tell you the story of a good idea that came up to the right people at the right time to provide a sustainable solution. The agenda for today is a brief introduction of the company, talking more about our solution and where are we now. So I am part of a group of creative problem solvers committed to the vision of unlocking the potential of floating offshore wind to accelerate the energy transition. We at Principal Power are a global leader in floating wind foundations, founded in 2007, with 120 talented and passionate people from 20 nationalities with offices in California. We were born in California, Portugal, France, Japan, and Texas. So we do have really a global outreach. Our patented engineering floating solution is a spinning of the coast of Portugal, Scotland with 75 megawatts of power, delivering electricity to the people living in those coasts. What is our engineering floating foundation? The WindFloat is a 3-column semi-submersible hosting on one of the columns a wind turbine. We say that it is turbine agnostic. This proven technology has over 14 patents. And what is the story behind it? It all started in 2007 with the vision of 4 guys in California led by a pioneer in offshore floating wind, Ala Weinstein. The 3 people that started this was Dominique Rodier, Alexia Obolt, and Christian Cermelli. They were naval architects from UC Berkeley. that designed the mini float to serve originally marginal field oil and gas fields. So the good idea was to put a turbine on top of one of the mini float columns. Why a semi-submersible? Because it has a 6-decade track record in the oil and gas industry that could work in California deep seas. They had the good idea, but lacked the expertise in electric grids and transmissions. So they invited Ala, an electrical engineer from Stevens Institute with a trajectory of trying different inventions. The right people forming the team was complete. The good idea and the right people were there, but the question was who would invest in this new concept? The concept was wave tank tested in scale model 1:96 in 2008. It was not the right time for California. It was the right time for Portugal. Funding was secured in 2009 with EDP, the large Portuguese utility company who wanted to depart from the use of coal to generate electricity. Ala told me the story of being in Portugal in a meeting with EDP, thinking about the place to build the Windfloat 1. She looked from the EDP building at the other side of the bay, what seems to be a shipyard. Liz Nave was then selected to build the Windfloat. The prototype Windfloat 1 was fabricated and installed off the coast of Viana do Castelo, offshore Portugal, in 2011. The proof of concept through demonstration was completed with a 2-megawatt turbine in 2016. Whenever you see, this is the Windfloat Atlantic. There are two projects here that you can see. The Windfloat Atlantic on the left, that it hosted three 8.3 megawatts of Vestas wind turbines. It is 20 kilometers out of the coast of Viana do Castelo in Portugal, certified by AVS. And what it is important, it was feed-in tariffs. And the equity financing was completed with a strong international sponsors. And it was the first bank finance floating wind farm. Because of course, we develop projects, we design projects, but we need to prove that they are first viable and that they are financeable. Then we do have on the other side the Windfloat Kincardine, project. It was first a retrofit. The Windfloat Atlantic 1 was retrofitted, tow out to off the coast of Aberdeen, and did the next testing, the next pilot testing. Then we started adding the next units to get a total capacity of 50 megawatts. So there are 5 units of 9.5 megawatts each, plus the 2 megawatts that is still working. The location, as I mentioned, is 50 kilometers off the coast of Aberdeen. And if you see this, the spinning, I was there last June, and what can I say is that it is just so majestic. This, one of the another project, pre-commercial project, is the EDF L'Éolien Flottants du Gulf of Lyon, which features 10 megawatts of offshore wind turbines on 3 wind floats units. And this is 16 kilometers off the coast. Environmental conservation is at the heart of this project and has been a central consideration in the design of the project. The project is installed in the natural park of the Gulf of Lyon and is the first floating wind project to be located in a marine reserve. And what you are seeing in the video is what it is called the biohuts, which are fish nurseries that were installed in the columns of our wind float. And the project is going to come online in 2023. So how do we get there? So this is the whole story of all the evolution. So the question was it fast? No, it took time. It took time and dedication and passion to develop one by one all these projects. And where we are right now is in what we call the industrialization phase, which is looking to produce, as was said before, not 1, 2, 3, or 5, but at least 1 or 2 1 unit per week in order to fulfill the ambitions of the state of California of 20 megawatts by 2045, and the U.S. ambitions to have 30 gigawatts by 2030. In addition to that, we pay this one of the core of our activities, our research and development, and what we call the innovation pipeline. We do have 2 main pillars: the digitalization, where we have partnered with other industry players and the academia to come up with a digital twin. Another example of collaboration is the Atlantis project, where we are working on robotic solutions to enable efficient operations and maintenance activities in floating wind. The other pillar was the technology expansion, which are studying new technologies in mooring hardware, such as shared anchors. And another example would be the shallow float, which project, which is to develop innovative shallow water mooring solutions. But that is just a snapshot of all what is happening in terms of innovation. Just to conclude, I would say that what we have is a strong commitment with CO2 reduction, economic growth, affordable energy, energy security, environment, and environmental justice. Floating offshore wind offers an unparalleled ability to contribute to decarbonization. It is a mature technology, and it is essential to rapidly build out the energy needs of the state. This is my presentation. Thank you very much. And after the presentation, so I will be ready to answer your questions. Thank you.
Well, thank you, Talia. That was very informative. I really appreciate that. And it really goes to show that within this emerging industry, there's a lot of opportunity for new technologies and research and development and new products that come online, and that we really are at the beginning stages of this new industry. And we don't really know what the final technologies that are going to come out of this and the exciting opportunities that are going to come for the blue economy. And so this is kind of why we're starting to put this information out to a whole variety of different industries so that they can start to adapt some of the technologies and some of the products that they're working on, and then see how they can adapt to the offshore wind industry as it starts to deploy over time. And so I'm going to transition here into Jonah. Then I want to go to Ryan, and then have Sam do the bring us home. And then at the conclusion of each of the reports, we're already starting to get a whole host of questions. We really encourage the audience to submit questions via the chat, and we'll try to get those incorporated in at the end. And so Ryan, Jonah, if you could go ahead and cue up your presentation.
Thanks, Larry, and thanks, Talia. Wonderful presentations. I think really striking, and gives people a real understanding of what's going on. So, thanks for having me here today. I'm going to maybe speak a little bit about the journey we've been on as a company in a transition. Also, kind of how the world is transitioning to a cleaner and a clean energy future, not just cleaner. But before I dig into how we got to where we are today, I want to provide just a quick update on us as a company. As Larry mentioned, I'm with Aker Offshore Wind, soon to be Mainstream Renewable Power, or MRP. You'll see that moniker. Just as the industry is growing and evolving, so are we. Aker Offshore Wind has combined with Mainstream Renewable Power, another renewable energy company, also in the Aker family. This is an incredible opportunity to create an even stronger renewable energy company with now a combined 27 gigawatt portfolio across onshore solar, onshore wind, fixed bottom offshore wind, and the expertise that we bring to the to the party, floating offshore wind. So combining our early mover position in floating offshore wind and technical expertise with Mainstream's proven execution track record, will unlock new opportunities for us, and we're super excited about what's to come. But maybe a little bit about where we've come from. I think, Aker, the name Aker, some may know, some may not know, but it has a proud maritime heritage that dates back nearly 200 years. The broader Aker group of companies can trace its roots back to the Aker Mechanical Workshop, which was founded on the Aker River in Oslo, Norway in 1841. So we are now over 180 years old. Back in the 1840s, that mechanical workshop, which you see in the, I actually was able to grab a picture of this. It's in the hallway of one of our facilities just outside Oslo. It grew steadily and went through various forms as a shipbuilding company initially, an engineering company, and has many iterations through the decades. I'll fast forward to the 1960s. And that's where Aker really began to focus heavily on the oil and gas market, and perhaps most famously built the floating drilling platform called Ocean Viking in 1966. And if you look closely on that image on the right, kind of to the right side of that image, you'll notice a semi-submersible style drilling rig. Just a few years into its life, it was built in 1966. Just a few years into its life, that rig discovered one of the largest offshore fields ever found, called Ekofisk. That field, which was founded in the early 70s, 71, I believe, is just offshore Norway and remains in production today. But you don't survive for 180 plus years without changing and evolving. So through each iteration, our maritime heritage and innovation have proven to be our common theme and remain that way today. So after more than 5 decades, close to 6 decades of heavy focus on offshore oil and gas, we decided to pivot and focus on building a clean energy future. But what came next? We had been tracking the fixed bottom offshore wind market quite closely through the years, specifically in Europe and other parts of the world, but had been looking for a market to fully utilize our core competencies and expertise in floating structures, system engineering, umbilicals, which you think of power cables, and operations in offshore and harsh environments. Floating offshore wind ticked all the boxes, and it was a market that was quickly maturing. We were very fortunate to find Principal Power when we did. We are now the largest investor in Principal Power and shareholder, and made the decision to invest in the company and quickly accelerate our capability in floating wind, and ultimately launch a new company to become a developer as Aker Offshore Wind in July of 2020, right in the middle of the pandemic, if you remember. Since that time, we have continued to develop a global pipeline of floating wind projects and been an early mover in several markets, including in Asia and here on the West Coast in the US, among several others. So our combination with Mainstream, which I mentioned, is just the next step along our journey. For some sitting in the US, and admittedly in many parts of the globe, the idea of floating offshore wind farms can seem almost like science fiction. Not science fiction after you saw Talia's presentation, but for some, it still seems that way. But this is truly proven technology that is in operation today and that is expected to grow exponentially in the years to come, spurred by several countries' desire to decarbonize. In fact, the Global Wind Energy Council predicts there will be 16.5 gigawatts of floating wind installed by 2030. One such project, we believe, will be our floating offshore wind farm off the coast of South Korea. And Larry mentioned floating wind is a global game. We are early movers in Korea. We have been active in South Korea since 2019, and with our joint venture partner, Ocean Winds, we are in the process of developing what will become the world's first commercial scale floating offshore wind farm. Now, we define commercial as anything above 100 megawatts. For this project, we are targeting a total of 1.3 gigawatts. Our joint venture is one of 5 developers to have been granted the first MOUs in 2019 and 2020. Late last year, an additional 3 developers signed on. Each developer has an exclusive area offshore with sites to mature and process. Our JV has an exclusive area with 3 such sites. Very different process than what we have here in the US. While we are still in the permitting and consent phase of the project, we are actively planning for the next phases along with our partners. Mobilizing the large international supply chain and working through the execution plan to deploy the first commercial scale floating wind globally is certainly quite a challenge, but our KF Wind team, which is our JV, has made tremendous progress to date. Now, I'm not going to go through each component. The quantities, lengths, and weights of the equipment shown on the right-hand side or kind of the middle part of this slide give an indication of what it takes to deploy a truly commercial scale, about 1 gigawatt project. In particular, I want to draw your attention to the bullet point listing the parts and equipment. And this is very close to alignment with what Larry presented off the top. To build just 1 gigawatt, it will take approximately 75 floating arrays. I think Larry had 67, but we're let's say 70 to make it even. In California, the CEC has announced targets of up to 5 gigawatts by 2030 and 25 gigawatts by 2045. With some quick math, you can now start to get a feel for the magnitude of what other countries, including the US and specifically California, are trying to build here. But just like in oil and gas, executing safely is our top priority. It's our license to operate, license to do business. Operating these machines, repairing them, moving them, these are harsh jobs, and they can be hazardous jobs. A recent offshore wind incident report by the G+ Global Offshore Wind Health and Safety Organization found that in 2021, the top 2 out of 10 high potential for incidents are lifting operations and working at height. These statistics are primarily for fixed bottom, but we believe potential for incidents can be reduced with floating, as major lifting operations, as you see in the picture on the lower left, and some of what Larry showed as well, those major lifting operations are during the construction phase are done onshore rather than offshore in a marine environment. So a big inherent advantage there. Now, I'll wrap up my remarks with a look ahead to the U.S. market. I'm stealing Larry's slide as well, but it's a good slide. So last year, BOEM announced up to 7 lease sales to take place by 2025. Earlier this year, 2 lease sales took place at the New York Bight and Carolina Long Bay on the East Coast. Earlier this year, we expect the 3rd auction to take place this year, as all eyes are on California, which will be the first auction in the Pacific and one where floating technology will take center stage. Next year, BOEM is also planning another 3 lease sales, including in the Gulf of Mexico, Oregon, which Larry also mentioned, and the Central Atlantic on the East Coast. I think it's fair to say that offshore wind has arrived in the U.S. I'll kind of end my comments there. I just really look forward to the discussion, and I'll turn it back over to you, Larry, for the next speaker.
Well, thank you, Jonah. That was very, very informative, and it really goes to show that the way the heading of this panel was laid out is really as this transformation between the oil and gas history that we have, and really transitioning into these new renewable emerging industries as it relates to the blue economy. And so what you're really seeing is a lot of the traditional oil and gas industries, and then the subcontractors that have been associated with those oil and gas industries are still doing oil and gas. We're not saying get away 100% away from the oil and gas, but are transitioning into this renewable field. And whether you believe in climate change or anything, the reality is the markets are dictating what is happening, and the markets are clearly heading in the wave of the offshore wind industry. And so thank you, Jonah, for your presentation. And it really showed, how industries are adapting to new market opportunities, and how the offshore wind industry is not just a California and the United States, but it's really a world industry that's happening simultaneously at the same time. And so I'm going to transition over to Ryan now. And so Ryan, I'll go ahead and turn it over to you.
Yeah, thank you, Larry. I will share my screen here. And here, can you see that?
Yes.
Great. So we'll take a slight detour from offshore wind, but stay obviously in the offshore renewable energy space. And so I'm Ryan Davidson, Business Development Lead at Callaway Power Technologies. And we design and build technology that generates clean electricity from the ocean's waves. So I guess to kind of start off, some of the key values of wave power are that it's very predictable, it's consistent, and what's really key is that it actually peaks in the winter, it's available all night and all day. And really, if there's open coastline facing wide open ocean.
I do have a question. Are you passing your slides, or because we are seeing just one?
Yes, yeah, I kept mine pretty bare bones. So this is right.
Okay, good. Thank you.
Just kind of keep into a story. I'll show a few pictures, and that's mostly it. But yeah, if there's open coastline, then there is significant wave power there, most likely. So just as an example, really everywhere from Los Angeles to northern Washington on the West Coast, you're getting about 30 to 40 kilowatts per meter of wavefront of theoretical wave power. So a very energy dense resource. So I guess to start off with the CalWave story, we were not founded in the 1840s. In 2014, our CEO, Marcus Lehman, was part of the inaugural cyclotron road cohort at the Lawrence Berkeley National Labs, and that's where the founding team for CalWave was born. In 2016, the team took part in the U.S. Wave Energy Prize, and out of 92 teams, the team was selected as one of 9 finalists, and then was one of the winners of the prize. So from that's kind of how the technology started to take off. In 2017, we had our first multi-million-dollar DOE grant, and then 2 more multi-million-dollar grants in 2019. Before COVID started shutting everything down, throughout 2019, 2020, the team was testing the drivetrain, testing the technology at UC Berkeley. And then the next year, in 2021, after building the device in the Bay Area, we deployed offshore San Diego at the Scripps Institution of Oceanography. So that deployment started in September of 2021, was originally scheduled for 6 months. But DOE said, you know what, leave it in the water longer. And we left it in there for 10 months. So we just recovered it here this past July. And so throughout, actually about halfway through the deployment in January, we received our 4th major DOE award. So that's $7.5 million. And that will be to actually scale up this system to 100 kilowatts. And that's what we'll deploy at PacWave. So PacWave is the new wave energy test site offshore Central Oregon. It's pre-permitted, grid connected, and the plan is to deploy there in 2024. So to kind of stick with the Scripps deployment then, to give a brief overview of the technology, our technology actually sits below the surface of the wave. So traditionally, devices either sit on top of the wave or on the seafloor. If you're on top of the ocean, then you have to significantly over-design your device just to survive the very harsh but also very rare storm conditions. And then if you're on the seafloor, you can be inefficient, and you're kind of more limited to very near-shore geography. So what CalWave does is that our technology sits below the wave, and as the pressure of a wave moves over the device, it moves in multiple degrees of freedom, and then the drivetrains that are internal in the device, generate power just like a wind turbine would. So we satisfied all 6 test objectives for the Scripps deployment. So it had safe operations in all sea states. The installation procedure, once towed to the site, only took about an hour and a half. The performance was as expected in the expected range for power output. The autonomous controls operated starting in November for the rest of the deployment. So that's kind of one of the key points of our technology, is that it operates autonomously. So it adjusts its depth within the water column to both optimize power output and to shelter away from storms, similar to how, say, pitch and yaw control would do for a wind turbine. The system demonstrated its reliability, survivability, and operated with over 99% uptime throughout the deployment. And a big question we get here is, well, what's the impact on marine life? So PNNL, pretty early on in the deployment, came out and verified that there's very little adverse effects on the surrounding marine ecosystems. And we actually see a potentially positive effect of the artificial reef. So we're actually seeing additional marine life around the device. So I guess to kind of step ahead to 2024 then, our plan is, like I said, to deploy at PackWave. So that'll be a 100 kilowatt system. And then scale, that's roughly doubled. So that's really about double the dimensions of this device. So you're looking at about 30, 35 feet wide. And like I said, since waves are a very energy dense resource, that system then will be able to be rated at 100 kilowatts. And then in the longer term, the plan is to, again, double the dimensions of that device, and then you're looking at 800 kilowatts. So in the long term, we hope to deploy those systems alongside offshore wind farms. So that's where these two kind of come together, is that there's kind of three target markets that we see. One of them being remote off-grid power for offshore operations like oil and gas. Another is for remote microgrids, where they're paying 30, 40, 50 cents per kilowatt hour or more. But kind of the big long-term one is co-locating with offshore wind. So we can both increase the power output from these offshore sites while also smoothing out that power production profile, because the production profile of waves and wind do not line up exactly at all. So one of the key drivers there is hopefully to not only share part of that permitting process, but to share supporting infrastructure like the export cable back to shore, offshore substation. And the idea is that we will be able to reduce CapEx significantly by sharing some of that offshore infrastructure. And so, that's about my presentation. I'm not sure we were reaching 10 minutes or anything, but I guess a few key asks that we have is that we are hiring for both electrical engineering and mechanical engineering roles. So if you or anyone is looking to join an exciting company in wave energy, then please reach out. And then also we are looking to build relationships and partnerships with in the offshore wind space as well. So thank you for the time, and looking forward to answering any questions.
Well, thank you, Ryan. Again, very, very impressive work that you're doing there. And what this goes to show is, from my perspective, is basically this new offshore wind industry is kind of like the anchor tenant that's coming into play. And what the anchor tenant does is it lays the groundwork by putting in all of this really expensive infrastructure that you have. And so what it does is it gives a whole bunch of opportunities for a whole bunch of other ventures that may not be profitable on their own. But if you co-locate these with other facilities, or you do those standalone markets that have really high cost and unique situations, such as oil gas platforms and other projects, it really goes in. And then the other thing I wanted to just highlight on with Ryan is that I picked up was how the university and these really innovative projects of how do you go from basically research concept to prototype, proof of concept, get your investments in there, and then really work towards scale up, to integrate into full production mode. And so what's happening with the offshore wind industry and a lot of these other co-benefits that go into play is what we're seeing is really a rapid acceleration of these industries that otherwise may take a lot more time. And so, Ryan, we really appreciate your effort. There was a lot of really good information. And so thank you so much. And I am going to switch over to Sam.
All right. Thank you so much. I'm going to try to not be repetitive, but I'm going to try to give sort of take what Talia and Jonah were saying and sort of give a little bit more structure to it within the offshore wind industry. And some of this is going to be, Larry gave a fantastic presentation at the start, so I'm going to try to not be repetitive towards him. So I am Sam Salustro. We are the business network for offshore wind. We are not a company. We're a nonprofit membership-based organization, much like the one that we're on a webinar with right now. We have a singular focus of developing the U.S. offshore wind industry and its supply chain. And we do that through a number of different ways. We offer market data to our members. We offer education to our members and non-members, training for businesses who are interested in getting into the offshore wind supply chain to understand what is the offshore wind supply chain, how they could possibly fit in, and very importantly, temporarily. So as where the project is and where their facet of the supply chain actually exists. Research and introductions. Not on this list is also events. We host a number of events all year long. And to talk a little bit more about that, we were founded in 2013 in Maryland as a collection of businesses who were advocating for passage of an offshore wind bill in the state of Maryland in 2013. Those businesses succeeded, got the bill passed, and quickly realized that they didn't know how to build an actual offshore wind farm. So what this collection of businesses was started traveling to Europe, learning from Europeans. They created what we call the International Partnering Forum. It's an annual convention. Last year we had about 3,000 people. Next year we anticipate having about 5. But it was intended to bring the European expertise over to the United States and have them partner with American companies to actually build these products. So we started in Maryland. Now we are national and international. We have 500 members that ranging from shipbuilders or ship repair people in Baltimore Harbor to international developers, much like Aker and Principal. So I'm going to, with our membership base and a couple of the tools, we kind of get to have unique insights into the market. And we use those insights to give information back to our members so they understand what their business opportunities are and who their potential business partners are. But we also use that information for research. So we partner with the federal government a lot and I'll talk more about sort of using that data to help understand how and what holes we need to fill to reach our national and state goals. So this is a map of what the U.S. offshore wind market looks like right now. Primarily located on the East Coast. We've been talking a lot about shallow floating turbine technology. There's fixed bottom turbine technology. It is a bit easier, I would say, and it is being built out now on the East Coast. We're going to have new lease areas in California that we touched on. We're going to have new lease areas in the Gulf of Mexico very soon. There'll be a combination of fixed bottom and floating. And then as I think Jonah talked about, we're going to have new lease areas in the Central Atlantic and the Gulf of Maine in the near future. And those will, half of the Central Atlantic lease areas and all of the Gulf of Maine lease areas will be floating technology. Another way to look at the same map is to look at it like this. This is sort of previewing a lot of the data that we have. Under contract, so the state and a developer have agreed to for a power exchange in exchange for monetary compensation. Under contract is about 17.6 gigawatts. On the East Coast, states have a demand profile of about 40 gigawatts. We talk about California singularly being 25 gigawatts at the end of the day. Currently, it's about 40 on the East Coast. That's going to grow pretty quickly in the near future here too. Total, it's pretty easy to imagine the U.S. market becoming a 110 gigawatt market in the near future. Over here is major facilities, manufacturing centers, or major suppliers that are either coming online, expanding their operations, or building entirely new facilities. We only have 7 turbines in the water, but there's already been $12.7 billion invested into the U.S. market. These are sort of structural investments. So supply chain, either new factories or expanded factories, port upgrades, new vessels. There's been 23 announced new vessels here in the United States. And what what really helps our members and what really helps us with this research component is this area right here. We run Supply Chain Connect. It is a free database for companies to profile themselves as able and willing to participate in the offshore wind supply chain. That was originally designed as a way to have Europeans find American businesses to partner with. We also encourage American businesses to partner with each other using that platform. Since President Biden has come into office, the number of entries within that database has nearly doubled, and now we have about 30 or 3,000 companies from 46 different states that have self-identified as willing and able participants. We also track the number of the contracts in the United States. These are publicly announced contracts or publicly disclosed contracts, and about 1,000 already. Again, we have 7 turbines, but we've identified about 1,000 contracts. And interestingly, 61% are U.S. companies, or 84% are companies that at least have a U.S. footprint. So while this is a very international industry, a lot of work is being done here in the United States. And I went with the theme of the title, and I want to profile a couple things. So we heard how Aker is transitioning from oil and gas into offshore wind. That is very, very common. So of those 1,000 contracts that we've been able to identify, 25% of those are going to companies located in the Gulf of Mexico. And that's before we've even seen a project come to life in the Gulf of Mexico. So that 3,000 entities, here's a smattering of them. Of course, they're going to be kind of clustered right now where there actually is activity. But here in the Gulf of Mexico, there's a lot of activity. There's a lot of suppliers that already exist and are supplying the market. Here in the West Coast, we're just building it up. We actually are partnering with the federal government or not partnering with the federal government. We're doing it on our own, but we're working to engage as many companies on the West Coast as possible in support of California and Oregon's goals. Again, Jonah already touched on this. It's using a lot of technology that's already very common in the Gulf of Mexico. Here's a picture of Block Island. These are called jacket foundations. They were made by Keystone Engineering in Louisiana. This is something that Keystone knows how to do. They know how to build. So when we needed to build the first U.S. wind turbines, they went to the Gulf of Mexico to use that expertise to do it and combine that with European knowledge. Larry kind of touched on this for the West Coast, but we have a national goal of 30 gigawatts by 2030. That's 2,000 wind turbines between now and the next less than 8 years, 7.5 years. That's 3,000 miles of cable. We did a report with the National Renewable Energies Laboratory, and we did demand profiles, and we know that we need 5 wind installation turbine vessels. This is where, this is sort of the surface level, but we're trying to use the information that we have to further break down each of these components into either assemblies or subassemblies, and determining what the capabilities are and the abilities are within the U.S. manufacturing sector to supply these. So Larry talked about, I'm sorry, Larry, it was like 100 turbines a year or something like that. I can't quite remember. Do we have that capabilities, especially here on the West Coast, where we're going to try to locate a new manufacturing base? Do we have that capabilities? So we're using the tools that we have available to inform where our holes are, and if there are companies that are on the cusp of being able to be major suppliers, but they're either lacking certifications or they're lacking some sort of expansion that they need to do, and using that to help inform stakeholders how to move forward.
We have about 1 minute there, Sam.
Great. I'm pretty much done. So,
okay, cool.
Second thing that we do, we use all the knowledge of our members, and we come up with policy briefs, again, to sort of lay out what the needs are of the offshore wind industry. And we published this, since we're talking about floating with California, we published this about a year ago, and it lays out sort of first steps that stakeholders and governments can be taking in conjunction with each other to make sure that they're sort of opportunity ready. Okay, and that's it for me. So would love to connect with all of you. I'm Sam at offshorewindus.org. Hopefully that's a pretty easy email address, but it's great to talk to everyone.
Well, thank you so much, Sam. In the first place, I want to just encourage everyone to join a business networking group. That's one of the core things about the offshore wind industry, is that the industry as a whole is really working together to accomplish these things, because they've recognized that although they're in competition with each other, is when you develop a whole new industry, there's a certain level of cooperation that needs to happen in education, lobbying, advocacy. And as you can see, $12.7 billion of investment to date. That's a significant amount of investment. And it's these opportunities like the Supply Chain Connect that you mentioned, is how individual businesses can get their name forward and say, look, we would like to participate in the blue economy, which is the offshore wind industry is doing. And how do you get your individual business and get into the supply chain and really start to develop this system? And again, I'm focused on California and the United States manufacturing industry. We want to see these new industries in the United States, in California, in Humboldt County, and in these communities that are going to be looking at this offshore wind industry. And so with that, I'm going to just, in the short amount of time that we have left, I'd like to have just a quick conversation about what you see as the largest barrier to your company succeeding in this offshore wind industry. And so I'm just going to start out with you, Ryan.
The biggest barrier?
Yes.
Yeah, I mean, I guess I would preface it by saying that I don't think any of these are barriers that'll be here forever. But of course, in the US and really globally for wave power, it's a nascent industry, and we know that. And, you know, for example, with wind, we've converged on a single design with the 3-blade horizontal axis wind turbine. And at this point, it's obviously just scaling up and growing larger. And now we're talking about 15 megawatts per turbine. And we just haven't reached that point yet with wave power. But we're confident that with our submerged pressure differential system and our autonomous controls, that can be us.
Well, thank you. So Talia, as you saw, these production levels are going to be pretty significant. What are you going to need to do in order for Principal Power, in order to meet the production levels that the offshore wind industry on the West Coast is going to need?
So you always ask, what is the challenges? The biggest challenge is we need ports. And of course, I know the efforts that your port is doing, and that's what we need, ports. But for internally, what we are engaged is with what we call the industrialization project or program, where we are screening all over the world. Because as Jonah mentioned, it is not only in one place, but it is in all over the world that is happening. So we are screening all the facilities that eventually can manufacture 100 units, which means 300 columns in our case. And what I see happening is that we need to have in the United States a lot of collaboration between the different manufacturing facilities. The work that is doing VNOW is just amazing and excellent in getting all the conversation going on in the industry. So for me, it is collaboration. That means first, of course, investment and long-term view, short-term view and long-term view about the projects, and getting up to scale after what is needed in the projects. And of course, whenever we're talking about construction, we're talking about shipyards, and that is something that has to be also looked into it. But remember, the shippers won't invest in upgrading their facilities if they don't see the pipeline of projects. So we need the pipeline of projects. And that is what is being brought with the auctions that are going to be happening. So as I said, our view is that we do have to develop the capabilities, and we need to have the supply chain ready. We need to have ports, of course, and we need to accelerate the permitting process.
Okay, well, thank you. And Jonah, I'm going to ask you the same question and really focus. We haven't really touched base on transmission, workforce development, and kind of supply chain. But what do you see as being the major issues or barriers?
Yeah, I see them as challenges, right? And I think if you had asked me the same question, 4 or 5 years ago when we really started to get serious about it, it was: is there a policy? Is there a goal there? And we've seen that movement over the last few years, not just in California but across the globe, various states. I think Sam, you mentioned it. Almost every East Coast state now has a target, which is great. But today, I mentioned it in the comments here, kind of where I see the three main challenges are around port infrastructure and the upgrades necessary to support the industry. And, we don't talk about this a lot, but I've started to talk about it, is the coexistence at the port. There's other stakeholders, other users of that port that have to be at the table when we're talking about these port infrastructure upgrades. And I think that's super important for the long-term health of the port, of the industry. Second is the transmission challenge. Larry, you laid it out well in California. That's well known, not just in the North Coast, but I think across California to meet their long-term goal of bringing 100% clean power onto the grid. There's a lot of transmission upgrades that are going to be necessary. And third, supply chain / workforce development. I think that goes hand in hand. And Sam talked a little bit about that. I'm an industrial engineer by background. So the industrial engineering challenge, I think, is really fascinating here. To get 1 or maybe 2 units out per week out of a port, reliably, safely, high quality, and producing power in a matter of weeks once it's commissioned. That is a true industrial engineering challenge. And then I'll wrap with the stakeholder piece. I think ensuring that all these various stakeholders that are new to offshore wind, the fishing community is important to keep at the table and have that open and frank discussion about what are the challenges, what are the modifications, what are the what needs to be done to make sure there's a coexistence. Onshore, we talk about cable landings and so forth. These are coming into areas that we have to be very respectful of where those are coming into. So tribal and other stakeholders onshore are really important. So lots of challenges, also a lot of opportunity. And I think the economic upside here is tremendous, especially in communities like Humboldt, like down in Morro Bay. I mean, these are just tremendous, multi-generational career opportunities for a lot of folks, which I think really important as we go forward and start deploying, as some secretary has famously said. So hopefully that gives you a sense of where I'm at.
Excellent. Yes. Yesterday, I met with the executive directors of, San Diego, LA, Long Beach, Humani, San Francisco. All the California ports are really focused on offshore wind. And really it is, how do we integrate into the existing ports and all the supply chain and containers and everything else that's going through the ports, and deal with the congestion and the commercial fishing and all of these issues from a ports perspective that we need to address. But Sam, I'm going to bring it to you. And again, I really encourage people to join business networking groups such as yours because of all the great work that you do. And so if you can kind of let us know what you see in the future of offshore wind.
Thank you. The main things were really hit hard, which is we really need investment into our infrastructure. We have a whole transmission working group, which, is, we talk about offshore wind, and we spend half of our time figuring out what onshore transmission policy is, I'll introduce a little new one, which is, and I think, Ryan touched on it a bit, which is collaboration. We encourage the East Coast states all the time. They can't do it alone. States really need to be working together, sharing resources, and allowing, supply chain collaboration and workforce collaboration across their borders. And that's tough because procurement is done on a state by state level, and trying to encourage them to look beyond that. The West Coast really has a challenge where they're going to try to ramp up even faster than the East Coast is doing, which is amazing. And they can really learn from East Coast experiences and really begin, California engaging Oregon, engaging Washington State to really have a unified West Coast action plan towards developing offshore wind. California has some of the biggest targets in the world right now, but even that, they're going to need help from other states to make sure that they can achieve those goals. So we encourage states to always be thinking that in order for this to be able to go at the speed that they want it, in order for development to go at the speed that they want development to go, they're going to have to bring in as many partners as possible to get it done.
Well, thank you, Sam. I really appreciate that. I want to do a time check with Matt. Obviously, we could continue going for a long time, but I want to do a reality check here. And if you want to close it out, or if you want us to continue, I defer to you.
Well, we could continue. It's just we can go for another 10 minutes or so. Now, I think we all have meetings. I have one at just about 15 minutes. So we can go another 10 minutes if that's okay.
Okay, that sounds good. And so again, what I would like to kind of hear from you is any sort of closing remarks that you guys would like to add. And again, as we said, we shouldn't hesitate to give your own company a pitch here, because you're doing such great work and this is a good opportunity. And so I'm going to start with you, Talia, and if we could, keep it to, about, 2.5, 3 minutes, that would be great. So we can give everyone an opportunity.
Yeah, if I had my crystal ball, what I would say is that, as I mentioned at the beginning, this is the opportunity of our generation. And what I see common is that as it happened with the Industrial Revolution in the 1900s, this is the opportunity for California and the United States to become the beacon to this industry. So I'm seeing having this all investment and those accelerated changes that are going to be happening. And then California and other parts of the United States, just instead of importing goods, just exporting the technology, as we are right now with my company, because we're a California-based company, exporting the technology, not only the technology, but exporting all the different elements for this technology to happen. So that is my forecast. It's not a wish list, but it is my forecast, because that's I'm seeing happening. And as the other thing is that, as Jonas said, for me, the challenges means opportunities. And that is the opportunity that we have all now.
Okay, well, thank you so much. We really appreciate Principal Power and all the work that you've been doing. So, Jonah, I'll turn this over to you. Any closing remarks that you'd like to add?
Honestly, not really. I think this was really a healthy conversation and great questions by the audience as well. I think super engaged. So thank you for that. I think from my perspective, coming from the oil and gas world for almost over 15 years. This is so exciting to see, a birth of an industry in not only the West Coast with floating wind, but really globally. This is going to be an exciting time for the next, decades. This is not a fly by night kind of industry. This is going to be here for a while, and I'm excited to see where it's going to go. So. I'll keep it there, short and sweet.
Well, great. I want to thank Acre Offshore Wind, and Principal Power in particular, because those two organizations really held our Humboldt Bay's hand in the early on and really helped us to get educated in this. And so I can't thank those two companies and many others in particular for helping to educate us along. So I'm going to turn it over to Ryan and see what your closing remarks are.
Yeah, thank you, Larry. I guess to kind of build off Jonah's point there, unsurprisingly, some of the larger energy players, might find it easy to drag their feet in a situation like this where we're building new industries. But the fact of the matter is, the energy transition doesn't care, and it's going to happen anyway. And offshore wind, it's, at least in Europe, has been leading the charge, and it is starting to lead the charge here in the U.S. as well. But to kind of tie in wave energy, we don't see offshore wind as a competitor by any means. We see it as a way to build partnerships and to, increase the power that we can get from these offshore sites while kind of reducing costs for everyone involved. So, to continue this conversation, reach out to me at ryan@calwave.energy. And like I said, we're hiring for multiple engineering positions. So looking forward to continuing these conversations.
Okay, great. And so Sam, I'll turn it over to you.
I'll take the opportunity to do a shameless plug too. So if you are, our as I said at the beginning, we're a nonprofit, and our goal is to drive supply chain development in support of offshore wind development. So I know that we have entrepreneurs on here. I know that we have business people on here. So connect with us. Hopefully we can help you. I'm sure the world is going to turn its attention towards California. So, get ready for all the attention that you're probably going to be getting pretty soon here. But connect with us. We have tools, we have education, we have events, all designed to be helping you get into the business. So I will do that. That's our shameless plug here at the Business Network.
Okay, so I want to give Humboldt Bay a shameless plug here as well. With Humboldt Bay, we're a former timber-based economy, and our port, it went through some hard times and was really was collapsing with the timber industry. We have aging infrastructure. And so, as was mentioned, this $12.7 billion of investment, this offshore wind industry is really giving new life to ports and port industries and the whole blue economy and everything that goes off of those. And so for ports, I think this is really a forward-looking industry, and so that we want to play a part in. And so I can't thank BlueTech Global enough for really putting on webinars like this and connecting us and doing the outreach to all of you that were able to listen to this. And so we really thank BlueTech, and I want to turn this over to Matt at this point.
Perfect. Very good. Yes. Thank you, Larry. Man, appreciate that. I love the plugs, man. We got to talk about what we do. Talia said it's. She's right about this. It's we're in this together. It's a fantastic opportunity to collaborate. Collaboration is important. So I really appreciate each and every one of you being on a panelist today. So just thanks again for everyone. I've put the link for BlueTech Week in the chat box for everyone's reference. We're going to have a powerful focus on the offshore renewable energy sector this year at BlueTech Week from multiple angles. So if you're in the industry or want to be, this is the time to attend BlueTech Week. Thanks, Larry. You did a fantastic job moderating. I really love the energy you brought. So just thank you so much. I really appreciate it. And of course, to our panelists, Jonah Margulis from Aker Offshore Wind, Sam Salustro from Business Network for Offshore Wind, Ryan Davidson with the upcoming and amazing CalWave Power Technologies, and Talia Kruger, a fellow TMA BlueTech member from Principal Power. We'll have our next BlueTech Global Connect on October 20th of this year. The theme will be supporting a targeted, responsible, and sustainable blue workforce, one of the big topics of today's discussion. So after this meeting, we'll send a thank you to all of the people who participated and the email addresses of the people who presented. Thanks again for being a part of the BlueTech Global Connect today. And we'll see you at the next one on October 20th. Thank you, everyone. Ciao for now.
Thank you.